Imagine a computer so powerful it doesn't just crunch numbers. It might be borrowing brain power from alternate realities. No, this isn't a science fiction movie. This is real, and it's happening right now, in a lab powered by Google. They call it Willow, a next-gen quantum processor that's not just fast. It's unsettling physicists. Why? Because what it just did challenges how we think about time, computation, and maybe even the nature of reality itself. Buckle up. Today, we're diving into how one chip might be the first real evidence that parallel universes aren't just theory. So, let's start with what Willow actually did. In early testing, Willow was handed a problem, a mind-bendingly complex computational challenge known as a quantum random circuit sampling task. It sounds fancy, but here's the kicker. This problem would take the world's fastest supercomputer over 10 septillion years to complete. That's a 1 followed by 25 zeros, longer than the universe has even existed. Willow? It solved it in under 5 minutes. Think about that for a second. A problem that would outlive the stars, answered while your coffee is still hot. So, what's going on here? How can this tiny chip, no bigger than your hand, pull off what seems physically impossible? Well, that's where things get weird. To understand why this is such a big deal, you first need to know how quantum computers differ from the laptop or phone you're using right now. Classical computers, like the one in your pocket, use bits. They're either a 0 or a 1, like light switches, on or off. Quantum computers use something stranger, qubits. Qubits can be both 0 and 1 at the same time, a concept called superposition. But it doesn't stop there. Quantum particles can also become entangled, meaning what happens to one instantly affects another, even if they're on opposite sides of the galaxy. These two phenomena, superposition and entanglement, are what give quantum computers their incredible edge. They don't just try one possibility at a time, they explore many outcomes simultaneously, like flipping every coin, every way, all at once. Now back to Willow. Unlike earlier chips, Willow boasts over 100 qubits, each one doubling its processing potential. That means it doesn't just test faster than older systems, it jumps light years ahead in computational depth. More qubits equals more parallel paths. But here's the jaw-dropper. The calculation Willow completed was so complex, some physicists say no classical machine on Earth could replicate it. Ever. And that opens a chilling question. Is Willow solving these problems alone? Or is it tapping into something else? One of the boldest interpretations of quantum mechanics is called the many worlds theory. Proposed by Hugh Everett and later championed by David Deutsch, it says this: every quantum event doesn't collapse into one outcome. Instead, every coin flip, every decision, every particle's movement creates a branching timeline. Most of the time, these alternate worlds are sealed off, unreachable. But quantum computers, they might be doing something radical, collaborating across those worlds. Some scientists suggest Willow's breathtaking speed is possible because it's not just calculating here. It's potentially spreading the load across a multiverse of processors, with the final result emerging in our universe. It's a mind-blowing idea, like billions of invisible copies of Willow working together, then vanishing the moment the task is done. Now, before we all jump into portals, it's important to say this is still a theory, a beautiful, haunting, maybe too good to be true theory. The mainstream view, known as the Copenhagen interpretation, says quantum systems don't need other universes. They're just working with probabilities. When we observe them, those probabilities collapse into a single outcome. No multiverse required. So, is Willow proof of the multiverse? Not exactly. But it might be the first step toward experiments that could hint at the truth. Even skeptics agree. Something extraordinary is happening. At this stage, Willow's achievement is still theoretical. It's like building the world's fastest jet and flying it in a wind tunnel. Impressive, but not practical yet. Quantum computing faces massive hurdles. Scalability? We'll need millions of stable qubits. Error correction? Quantum states are insanely fragile. Real-world applications. We're still figuring out how to use this power, but if we get it right, the rewards are beyond belief. Quantum computers could revolutionize drug discovery, unbreakable encryption, simulating the universe itself, and maybe, just maybe, prove we're part of something far larger. So, is Willow the future? A fluke? A whisper from a neighboring universe? We don't know yet, but one thing's certain, we're standing at the edge of a new kind of science, where reality, computation, and imagination begin to blur. And in that blur, the questions get more exciting than the answers. What if the fastest computer ever built isn't working alone? What if reality itself is just one of many? And what happens when we finally learn how to compute across them all? If this kind of mind-expanding science excites you, hit that like button and subscribe for more curiosity-driven journeys into the unknown. What do you think? Is the multiverse just a theory? Or are we closer than we think to proving it's real? Drop your thoughts in the comments. And until next time, stay curious.